I love math art. This is something I made on Desmos. It's a bunch of parallel lines, and the opacity changes from 100% down to 0%. And I think stuff like this really, really looks pretty, and it looks cool. And every time I see it, I'm always like, man, I think mathematics is so beautiful. And so let me go ahead and define math art here. Math art, in my opinion, is this idea that you start off with something mathematical, then you turn it into art. Like you make it look pretty, or you make it look cool. But that's not what this talk is about. This talk is actually about art math. And all we're going to do here is flip that relationship and say that if we start off with art, can we turn it into a mathematics? So this idea kind of got seeded in me when I read this book called Interaction of Color by Joseph Albers. He's a color theorist, and he taught a class at Bauhaus. And he realized that his students had a really hard time telling the difference between color intensity. So take a look at that image and ask yourself which one's the reddest red. Not anymore. He compared the intensity of colors to music and saying like, those are both happy birthday to you, but one is in a higher key. And so he had this exercise that he came up with students. I want you to think of those 4 reds as 4 notes in happy birthday to you. And that what he wanted his students to do was to change those 4 reds into a different key. So he cut out a bunch of blue squares, and he asked them to match each blue square like this to the reds. Right? Now, just take a second to look at the pile of blues there and do some imagining for yourself. Which blues do you imagine will match with which reds? Why I wanted to give you some time to do that is because I think that if we talked with each other, we would actually find that there is some logic to this. This isn't just a feeling that Albers has, this isn't just a feeling that you have, but when you look at that image right there, you're kind of presented with a logic. And the thing that really blew me away is Albers is writing about this. He said, again, the aim of this exercise is to present a study aiming at one distinct relationship. He called this parallel intervals. Now, as a math teacher, when I read that phrase, I was like, oh my gosh, this person who's a color theorist is thinking about these colors as a parallel relationship. The blues kind of have a similar step as the reds down there. So here's where I think art math kind of gets started. We start off with art, and we can turn it into a mathematics. Me as a math teacher, parallel relationships, I can start to envision that kind of as a parallel line. You can maybe see a little bit where this is going. You kind of arrange them there from dark to light. Well, you can imagine how they kind of continue off to one side and continue off to the other side. And so let's just play and say that these 2 colors are parallel to each other, and we can display them like that. Well, now a whole world of new mathematics, stuff that I'm going to ask like tongue-in-cheek, just as a silly and playful way. What's a perpendicular color to that blue? Yeah, actually talk to each other. I don't know. The next slide will not reveal the answer. All right. What's a skew relationship supposed to look like? What colors are skewed to each other? They're defined not by their parallelness. They're defined not by their perpendicularness. Is there an intersection of those 2 colors? What does that intersection look like? And how is that true for both of those lines? So this idea of art math, it plays with what Malcolm Gladwell calls the rule of the analogy. It's that 2 things that you're analogizing are not identical, and to the extent that they are, your analogy is useless. So he uses the example of comparing Macintosh apple to a Red Delicious apple. If you tell students to do that, what work is there to be done? Now, there's an apple, there's another apple, they kind of look similar, you kind of get what there is to get. I kind of think some examples of math art tend to do that. My students aren't really vibing with parallel lines, let's make it look pretty. Let's make parallel lines look like lots of parallel lines. Instead, Malcolm Gladwell says that what's interesting about writing, what's interesting to us as humans is imperfect analogies. And it's the idea that what actually will draw you in is the imperfection. Right? And I think that's really, really true of the things I find interesting. If someone were to tell me this apple is a lot like an orange, well, now I'm sitting there and I need to figure out what the heck that person means. And there's questions that come from that. there's conversation that comes from that, and there's not necessarily answers, but there's just exploration. That's how I feel about Artmath. The idea that we can actually compare something like parallel lines to parallel colors. Right? That opens up questions like, what are perpendicular colors? What are skew colors? And those are not questions that I or anyone else has answers to, but it's ones that we can engage with our students with. Thanks.